up, and that would be a lot of content. You did some logarithms in Algebra 2, I believe. So you've talked about the basic properties, you've talked about graphs, you've done equations. We are just going to take it all a little bit further. So hopefully some of this is familiar, but just in case it's not, I like to start back at the basics and assume you don't remember anything, and then we'll build up from there. So first, if I am talking about a logarithm, we have to know what a logarithm is. So that's our first slide, just the definitions. With a logarithm, they always have a base that has to be a positive number other than 1. And the definition, if you have like y equals log base a of x, it means x equals a to the y power. The base has to be a positive and the x has to be a positive. So essentially what a logarithm is the exponent in an exponential equation. All right, we've seen lots of exponentials. If I said like 2 to the x power equals 8. Could you tell me what x had to be? What is x? 3. That could be written as a log. You might see log base 2 of 8, and it's saying the same thing. 2 to what power is equal to 8? And so it's just that exponent is what you're finding with the log. So the log means the exponent. A good way to go back and forth between the two is to think about the base. So this is a base of a. So if I'm going to write it as an exponential, you start with your base, and you always go across the equal sign. So it's a, what we're looking for is the exponent, equals x. So you might remember drawing those arrows in Algebra 2 to go back and forth between them. With exponentials, the base has to be positive, so that's still true here. If you take a positive number to a power, you get a positive. So both the a and the x have to be positive numbers. The only thing that could be a negative is that missing exponent. That's the only place we will see that. So first, we're just going to practice going back and forth between the two. So if I said 1.2 to the third power equals m, I'm not asking you to solve it or anything. I want you to write this with a log. So the base of the log, that's the little number here, is the base of the exponential. And the exponential, that's a number being raised to a power. So it's the log base 1.2. That 1.2, it's like a subscript, so it's a small number. You go across the equal sign. So it's log base 1.2 of m, and it's always equal to the exponent, so equal to 3. On B, if I give you a log and ask you to write it with an exponential, what's the base of this log? E. So that's the base of my exponential. So the e to the negative third power equals b. So we just need to be able to go back and forth. You guys try those two. So we always start with the base. So it's 3 to the c power, because the log is equal to the exponent, equals 5. On D, what's the base of my log? 3, same as the base of the exponential. And that base you write it as a subscript, go across the equal sign, so log base 3 of 9 is equal to 2. It's always equal to the exponent. All right, looks like we were doing okay with this. Next, I want to put some log problems up and see if we can solve them. So there's 2 different ways of solving them. You might be able to just look at it and evaluate it. If you understand what a log means, a log gives us the exponent, right? If you struggle with that, we can always turn it into an exponential. So if I ask you to find the exact value, Alright, so I don't want you to put it in the calculator. Your calculator has a log button, but the button just on the side, that's log base 10. This is a log base 2. So if you just type in the push the log button, it will give you the wrong answer. If you know what this means, it's looking for the exponent. It's saying 2 to what power would equal 16? 4. So some of you might be able to just look at that and say, I know it's 4. If you can't, you could set it equal to x and write it in exponential form. So that's saying 2 to the x power equals 16. How did we solve these types of questions on our test? How did we rewrite the 16? And you get x equals 4. Okay, same thing. Faster, obviously, if you just look at it and know, but if you don't, it's not a big deal. It only takes a second to write it out and solve it like a problem we've done before. So B, this means 3 to what power would equal 1 over 27? Of course, if you needed to, you write an equation and you solve it. 3 to the x equals 1 over 27. Common base, we know we can't change the 3, and so we get it that way as well. All right, you guys do these two. So 2 to what power equals 1? 0. If you wrote it out, you have 2 to the x equals 1. We can't change the base of 2, but you would change your 1 to 2 to the 0 power. So you get the same thing. This one, log base 5 of 25 means 5 to what power equals 25? 2. All right, are we getting to the point where we understand what a log is giving us? Okay. So let's try solving equations that we can't just look at and know the answer. So if I ask you to solve log base 3 of 4x minus 7 is equal to 2. Probably not one I just look at and know. So what could we do? What did I tell you to do on the first 4 if you didn't just look at it and know? Yeah, this one is already equal to something. So how do we write it as an exponential? Well, somebody can tell me. How do I write this without a log? What number do I write first? 3. You always start with the base to the second equals this whole inside, 4x minus 7. Now this is a pretty easy equation to solve. 3 squared is 9. If I add over my 7 and divide, we get 4. You should check on these. We just have to verify on any log, the base and the argument both have to be positive numbers. So all I really need to look at is if I plug in a 4, do I get a positive number? 16 minus 7 is 9, so it works. If I got like a negative 9 in there, I would have to say no solution. All right. Log base x of 64 equals 2. So we change it to exponential. What number do I write first? X. So it's x to the second power equals 64. How do we get rid of a square? Anytime you add a square root, you need, so we get x to be positive or negative 8. But we check it. On a log, both the base and the argument has to be positive. The only thing that can be negative is what it's equal to. So can x be a negative 8? No. So 8 is the only answer that works. All right. Do you guys think you could try a couple? I'll put 3 up here. I'm just going to give you a couple minutes. Get as many as you can. So if you don't get to all 3, that's no problem. Just try some. Everybody should be able to write these in exponential form. You always start with the base, the small number here. So it's x, we go across the equal sign, to the negative 2 power equals 16 over 9. Are we okay with that? Getting rid of the log. What does a negative exponent mean? So 1 over x squared equals 16 over 9. So if I cross multiply, divide, x squared is 9 over 16. How do we get rid of a square? With that, we do plus and minus. So that's 3/4. But when we check it, can x be a negative? It was my base. So positive 3/4 is the only answer that works, because the base has to be a positive number. B. To write it in exponential form, we start with our base. So I start with my 16. Go across the equal sign to the 3/4 power equals x. All right, 3/4 power. We've done that. How do I write that with a radical? 4th root of 16 cubed. What is the 4th root of 16? That's the 4th power. 2. And then 2 to the 3rd? 8. So we get x to be 8. Okay, argument has to be positive. 8 is positive, so that works. One more. So if I'm writing this in exponential, we start with the base, so that's 36. Go across the equal sign. So 36 to the x power equals the square root of 6. How would we have solved this if I put it on the last test? Okay, so I heard a square, and you can definitely square both sides. I also heard just changing this to a 6 squared, and both of those will work. And it really, you could even do both, it just doesn't matter which one you start with. So here, either to get rid of the square root, you would have to square both sides, or you could write a square root as what power? 1/2. Either option will work, it doesn't matter a bit. So then we have 6 to the 2x equals 6 to the 1/2, or if you had squared both sides, you would have 6 to the 4x equals 6 to the 1. So 2x equals 1/2, and x is 1/4. All right, so the key to these is changing them to exponential form, and then using strategies we know to go ahead and solve that. All right, I want you guys to do a couple on your own now. Doing better. Start with the base. So this would be 3 to the 2nd power equals x, and 3 to the 2nd is 9. Double check, that's positive, so we're good. This one, start with our base, so 2 to the 3rd equals 2x plus 1. So if we subtract the 1, divide by 2, we get 7/2. If I plug that in, 7/2 times 2 is 7, plus 1 is 8. That's a positive number, so we're good. All right. Any questions there? All right, so there's a couple other things we want to talk about today. Sometimes we are going to have to evaluate logs on our calculator, so I want to show you how to do that. If there is not a base written here, it's assumed to be 10, and that is what the log button on our calculator is. So if you look, if you have the graphing ones, it's like the fourth button up, it just says log. When you push it, it opens a parenthesis, so you would type in your 46 and close it. What do we get? Give me 4 decimals. 275, so we round up to 28. Did everybody get that? Below that, ln, that is the same thing as a log-based e, so it's just another type of log, but it is a special one. And we have an ln button on our calculator right below the log. So if I type that in, it says 8 times e. To get the e, you hit the second, and then the natural log button again. Should get 8.0794. If you had trouble plugging that one in, let me know. It's a little bit different. So we're only using our calculator if it's log base 10, so no base written, or ln, which means log base e. Bless you. Those okay? All right, last thing I want you to do today. There are some properties of logs. I'm going to have you write them down, and we will do just a couple examples with them today, and that's what we're going to pick up with tomorrow. Okay, so I want to get it in our notes and just talk about one piece of it today, and then we'll do more. You don't necessarily have to write this whole blurb down. That's just the domain issue we talked about with logs. The bases and the arguments have to be positive. So what you really need are these: the product, quotient, and power properties. That's what you need to get down. It has to do with exponent rules. We know if, like, I have 2 to the third times 2 to the fourth, we add the exponents. So if you have the log of, or if you have 2 logs being added together, you can multiply those pieces or break them apart that way. When we're dividing, we subtract exponents. So if you have the log of things dividing, you subtract the logs. I should probably let you write before I explain to you. So remember, a log is giving you an exponent. And we know if I said like 2 cubed times 2 to the fourth, that, what do we end up doing with those exponents? We add them. So that's what this says. If you have the log of 2 things multiplied together, you can do the individual logs and add them. It's like adding our exponents. Okay, dividing. If I said 2 to the 7th over 2 to the 3rd, what do we do with those exponents? You subtract them. And so if you have the log of things being divided, you can subtract those exponents. This has to do with a power to a power. So if I said like 2 to the 3rd, 2 to the 4th, what do we do with those exponents? Multiply them. So this piece is representing the exponent. This is another exponent, so it can come down. So you're multiplying the 2 exponents together. All right, so these are really just an extension of the exponent rules. I want you to write down these last 2 pieces. Again, you don't really have to write the greater than 0, not 1. That's just the rules for logs. Log base a, or a to the log base a of n. Okay, logs and exponents cancel each other out. So the log and the exponential are inverses of each other. They cancel them. So if you do both, this piece can cancel, the a and the log base a. And this is saying the same thing in reverse. And Now, all I'm going to do today to finish is I'm going to look at a couple of these and kind of touch on what that means. And then I'm done, and we'll pick up with the properties tomorrow. Okay. If you think about it with numbers, if I said 2 to the log base 2 of 8 power. Okay. What is log base 2 of 8? 3. What is 2 to the third? 8. So essentially what happened is we worked it out and got there, but if we had just dropped the 2 in the log base 2 to begin with, it was just equal to the 8. If I said log base 5 of 5 squared, if we work this out, this is log base 5 of 25. This is saying 5 to what power equals 25, which is 2. So we could have worked it all out, or we could have just said, well, originally these things cancel and we get 2. So it's just a shortcut. If you forget the properties, you can still get it, working things out. But if you remember it, it can sometimes save you some steps. So if I asked you to solve this one, x equals 3 to the log base 3 of 8 power. What would that equal? 8. You can just say the 3 and the log base 3 would cancel, so that is 8. Okay, we don't have to work out anything extra. All right, if I said log base 4 of the cube root of 16. All right, maybe this one isn't quite as obvious. The cube root of 16 is 16 to what power? So this is a 1. If we wanted to write without a radical, we could do just a 1/3 power. (16) is the same thing as 4 squared to the 1/3. So that's log base 4 of 4 to the 2/3 power. So can you tell me what it's equal to? 2/3. So we had to do a little more work to get there, but once we did, the log base 4 and the 4 cancel each other. All right. Are there any questions? Okay, there is a handout posted on Google Classroom. You guys have time to work on that and ask questions right now.